What rules do I need to remember related to arcs and chords? This is page 715. What rules do I need to remember related to arcs and chords? We're going to cover 3 rules today, and then you're going to do problems related to those 3 rules. In the same or congruent circles, two minor arcs are congruent. If their chords are congruent. Arcs are congruent if their chords are congruent. So a picture would look like you got a circle, and within that circle you could have 2 chords. And if chord AB is congruent to chord CD, then arc AB will be congruent to arc CD.
Oh, I get it.
Just kind of makes sense, right? That if the distance from A to B is the same as the distance from C to D, and you're in the same circle, or a congruent circle, then the arc measure, arc AB, has to be the same as arc CD.
Do you have water?
And if the arc measures are the same, then the chord lengths are the same. All right, the rule goes both ways. Got it? Turn the page. All right, if a diameter or radius of a circle if a diameter or radius of a circle is perpendicular to a chord, perpendicular to a chord, then it bisects the chord and its arc. If a diameter or radius of a circle is perpendicular to a chord, then it bisects the chord and its arc. So if you got a circle, diameter is a chord that goes through the center. If that diameter or radius is perpendicular to a chord, So if it intersects the chord at 90 degrees, then it bisects the chord. So segment AB would be congruent to segment BC. And arc AD would be congruent to arc DC. If a diameter or radius is perpendicular to a chord, then it bisects the chord and the arc. Any questions? All right, so if you're given that given arc MO equals 98 degrees and PO, P to O equals 9, and you're asked to find arc NO and segment MO. All right, so you've got a radius that intersects a chord at 90 degrees. So if the segment from P to O is 9 units, then how far is it from P to M? If P to 9 units, because it bisects it, right? So how far is it from M to O? 18, good. Now if arc MO is 90 degree or 98 degrees, if that arc is 98 degrees and these two arcs are congruent to each other, then how far is it? What's the degree measure from N to O? 49, right? Half of the 98, so 49 degrees, good. Clear? Okay, if or in the same or congruent circles, in the same or congruent circles, two chords are congruent. If they are equal distance from the center. Two chords are congruent if they are equal distance from the center. All right, here's what a diagram will look like showing that two chords are equal distance from the center. You'll have the center of the circle. Then you'll have a segment from the center of the circle to a chord. And the center to a chord. Those segments have to intersect the chord at 90 degrees. And if they are congruent, if the distance from the center to the chord is the same as the distance from the center to the chord, then the two chord lengths are congruent. Okay, so in this case, segment AB is going to be congruent to segment CD. And arc AB will be congruent to arc CD. Any questions? Okay, so draw this picture.
I'm starting to get really good at drawing circles.
Good. Okay, given information. A to C. A to C is, let's say A to C is 18. D to E is 20. And you're asked to find B to C. Okay, so you're looking for this piece right here. All right, if D to E, what do you got here? You've got a diameter that intersects a chord at 90 degrees, right? Diameter intersects a chord at 90 degrees. So what does it do to the chord? Cuts it in half. So if D to E is 20, how far is it from D to B? So that's 10, and this is 10. Okay? Now, do you see the distance from A to C? That's 18 units, right? It's a radius. Okay? So if you draw in another radius that goes from A to D, and you label it 18, don't you have a right triangle here now? And in that right triangle, can't you use the Pythagorean theorem to find segment AB? Okay, so segment AB, or let's call it little letter A squared plus 10 squared equals 18 squared, doesn't it? So A squared plus 100 equals 18 squared.
Why is it AC?
It was given.
That's AC 9.
Yeah, A to C is 18 units. A to C is a radius, isn't it? So isn't A to D also a radius?
Yeah.
All right. This is a case where you have to draw in a radius to create a right triangle so that you can solve the problem. Okay? Once you draw in this segment, you create a right triangle, ABD. Then you can use the Pythagorean theorem to solve for segment AB. And once you solve for it, you could subtract it from the radius and get BC. So this is 324. So if you subtract 100 from each side, then A squared equals 224. What is? Square root of 224?
14.9.
Yeah, you're gonna. All right, so you're gonna radical each side, and this piece right here is gonna be equal to 14 point what? 14.9.
It would go up to 15.
Okay, let's make it 15, just to keep it clean. We'll make it 15, for argument's sake. Okay? Just want to show you the process. Well, if A to B is 15, then how far is it from B to C? If A to B is 15, how far is it from B to C?
3.
B to C would be 3. Good. So the drawing's not to scale. But if A to C is a radius and it's 18, and A to B is 15 of it, there's only 3 left. All right, so B to C is 3.
That's kind of. You get the hang.
There's a problem in your assignment that looks like that today, so I wanted to give you a little heads up.
Why would B to C be 3?
Because this much of it is 15. A to B is 15, right? Well, A to C is 18, because that's a radius. So there's 3 left. All right?
Yeah, I guess
The picture's bad. It's really not to scale. I mean, the lines are straight, and it's a nice circle,
yeah, it's just
but it's not to scale.
D to E would be a lot lower.
Yeah. All right.